So, what is time? How can it be defined, measured, or manipulated with? Welcome back to the Fundamental Why. I'm your co-host Cary.
And I'm your other co-host Saahil, and today we have an episode on the nature of time.
So, before we begin and introduce you guys to some basic topics, let me introduce you to the overarching theme for this week's episode, and that's metaphysics. As you can probably tell by the name, metaphysics has parts of physics and philosophy embedded within it. It's basically the study of the fundamental structure of the universe through things such as time, being, and reasoning. And we're basically looking specifically at time because it's important in our lives. It impacts living animals, living organisms, and non-living things as well.
And so now, just to give you a little bit of a summary of how this episode will look like. First, we'll start off with the definition of time, try to set the basis for our whole conversation here. Then I'll talk a little bit about the physics theories. What does physics have to say about time? But this one involves special and general relativity. And we also want to have some philosophical connections and interpretations of time. And then, which will come to the most exciting part, I guess, of this episode, which will be a discussion where we answer a few questions. And then, lastly, of course, will just be another recap of what we've discussed and things you should take away. And so, now just to transition into this whole topic, let's think of time. So, time is everywhere in our lives, right? If you think about the number of clocks that we surround ourselves with. Right now, there's a watch on our wrist to tell me the time. We have clocks on the walls and in our digital devices. It's just everywhere, right? So we're constantly moving through schedules, making sure we're on time, completing tasks on time. And even think of our language as well. Our different verb tenses in our English language use time as well. And so we're really familiar with the idea of time, but if someone were to ask us what is time, then that becomes much more abstract. Right? We don't really know how to answer that, I guess, with the intuition of our daily lives. So now let's kind of move on to that definition of time.
Yeah, so that's why we're here. We're going to go over some currently proposed theories about time, and then we'll go over our personal opinions about it. So if you were to go into Google and type in what is time, currently you might get the Oxford Dictionary definition, which is time is the infinite continued progress of existence and events through the past, present, and future. Now already we can see the definition is quite subjective and there's quite a few nuances as well. For example, what can be defined as existence or events, and there's some key words at play there. The infinite continued progress. So time has to be infinite and continued. There can't be a stop of progress, so no change anymore, because then time wouldn't exist. And that's an interesting concept we'll discuss later on as well.
Okay, so now if we think about how time, to explain what physics says about time, let's start off with what we know about time. Well, at least we think we know that time passes the same for everyone, right? The time that passes for me, right now, I would measure 10 seconds, Cary would also measure 10 seconds, right? That makes sense. That's what we see every day. But what if I were to tell you that time is relative, right? What does that mean? What I'm saying is that time passes differently for different people. And, well, you might ask, like, the reason for this, and this sounds like something from, like, science fiction type of movie, right? But if we go back to 1905, where Einstein was, formulating his ideas on the nature of time and space, well, he came up with the idea of this whole relativity, and this is the field of relativity and how time changes. And the reason is because of, if we're traveling at different speeds, and we need to travel at a very fast speed, and when I say fast, I mean the speed of close to the speed of light, then you'll notice start changes in how you measure time relative to someone who's stationary. And this isn't simply an illusion; it's a real measured effect. And this is called Einstein's theory of special relativity that made him famous. That was really inspiring story. And now that we understand time is relative, the term for this is called time dilation, where time can change depending on how fast you move. And another way this can happen, where time can change, is also in the presence of gravitational fields. So if you're near a very strong gravitational field, you'll experience time much slower. And this is part of Einstein's general theory of relativity, where he makes more insights in terms of how gravity works. So there's these two ideas of how time is relative. Time can change either when you're traveling very fast or near a strong gravitational field. And these were the ideas that really changed the beginning of the 20th century and the physics understanding of time.
So, if we were to also take a more philosophical take on the nature of time, we would eventually land on something that philosophers Augustine and Kant once talked about before. So, time could be thought of as a framework created by the mind. You can think of it as like a number line. So, our brains know what came before what and what comes after, and it helps us define what happened in the past, the present, and maybe even the future. Without the concept of time, your memories would be like jumble, a lot of mix. You wouldn't know what happened before what. So time is a very helpful tool in reordering things and giving us specific structure to them. So time may not be seen as physical, but instead a mental framework created by us humans. And let's talk about another cool concept. If you take a more philosophical approach, that time is dependent on change and vice versa. Both of these concepts can be interlinked because when we think about it, when you see a movie scene or a hypothetical situation when time has stopped, for example, you will see no more change happen. For example, the leaves stop falling, the cars stop moving, everyone stops aging and undergoing biological processes. So there's no more change going on, and that's happening when time has stopped. So they can be seen as interlinked, change and time. Now to move on to another cool concept, and that's time is an emergent property, not fundamental. This basically means just like how protons, neutrons, and electrons, they are made up of more fundamental structures, such as quarks, time can be seen as made up of more fundamental properties. And what may these properties be, you may ask? Well, they could be, for example, relationships between matter. For example, if you guys know about atomic clocks, they're currently the most accurate way for us to measure time. They're so accurate that it would take 300 billion years for them to be 1 second off. And atomic clocks, they don't measure time in a sense. They measure something called radioactive decay, which is when a radioactive substance slowly decays and loses particles over a set period of time at a constant rate. So then the clock measures the radioactive decay, which is the changing configuration of the matter, not the time. So, in a sense, time could be seen as emergent and based on more fundamental relationships, such as the changing configuration of matter.
Nice, and those are really interesting ideas I heard there. I also want to add another philosophical perspective here. So let's consider understanding how, at least we say time flows, right? That's the idea. Many people think that time moves in that way, but time flows relative to us, or do we move relative to time? So there's those two theories. Number one is called A theory. So this means that time is dynamic. The first thing I suggested, where we are stationary and time kind of flows through us. So you can think of it as how only the present is actually real, and both the past and the future don't really exist. So think of it as a river flowing, where you have the future that flows closer to you as your time progresses, then it becomes your present, and then it'll flow past you and become your past. So there's that progression of time. We think of time as moving, and that of course matches our daily experiences. However, there's also B theory, which is slightly, I would say, kind of different than what you would expect, and how time is static, and it's actually us that's moving through time. So think of it as the past, present, and future are all equally real, and we're just experiencing certain parts of, say, that temporal landscape. And you can think of it like locations on a map, and we're kind of forced to move in one direction, and we're just moving through all these locations on the map, but all those locations still exist, right? And they're all quite real. And that also brings up another quite interesting, I guess, thought experiment, which would be the block universe idea, which is kind of what it sounds like. The universe is a block, and we're trying to scale down dimensions here, right? We can't perceive fourth dimension. So let's say space, we lived in 2-dimension space, so we can make the up and down the dimension time. And in that case, we live in 2 dimensions. A slice would represent 1 instant in time, and we would just be living through each slice. So you can imagine our lifetime just being that slice moving through the block. And why that's amazing is because it kind of suggests that the future is already predetermined. I guess it goes into those ideas of free will and determinism, because think of it like a movie almost, where you're watching a movie and you feel like every instant is real, but the whole movie's already recorded. So in the same way, you can say the whole block of the universe has already been like set in stone, and we're just experiencing each slice of that block. And that's the whole idea of the block universe theory. And now, do you want to kind of get us started off with the discussion? I guess.
Yeah, thanks for bringing that interesting concept in. That was quite interesting.
Yeah.
And then that will help us lead to the open discussion section, where we'll have a natural conversation, and then we'll start off with a guiding question and build off from there. So, Sahil, to start off, as we know, like as Einstein mentioned, time is just another dimension. It can be considered the fourth dimension. So why can we only move forward through this dimension and not any of the other ways, like back?
Well, I think that's a beautiful question, I would say. And the reason that that's quite a common question that's asked is because if we set the context here, when we say dimensions, at least we're used to spatial dimensions, where I can move up, down, left, right, forward, backward, right? So there's that freedom in how we can move. But Einstein treated time as a dimension, so you should expect being able to move freely through time in the same way you can move through space. But space and time are kind of different in that case. And here's my answer, at least my idea. I would say I believe that time moves forward, and I guess it's kind of related to the idea of entropy, and that's a very abstract idea. So how would you explain that idea of entropy there?
So for those of you who don't know, entropy is basically when, as we go on, entropy always increases. So entropy is basically like disordered arrangements of like atoms, and that can be seen as like unuseful energy, which is heat energy. So as time progresses, more useful energy like electrical energy slowly turns into more unuseful energy, and so order turns into disorder, and as time progresses you get more and more disorder. So because entropy always increases, you always keep getting more disorder. That might explain why time also increases in one direction, because that's how entropy works out.
Yeah.
What do you think?
Yeah, definitely. I guess your description of how energy going from more useful to less useful, that's kind of connected to how entropy changes. And here's also what I think of entropy. I know this is a very advanced concept. That takes a lot of understanding. But at least what I know is that another way to think of entropy is like the amount of I don't want to use the technical term, but it's called microstates. Think of it as configurations of atoms. So say I have two atoms here, both my hands are atoms. If we move them in different positions, that would be considered a microstate. So in the same way, entropy always increases in the sense that you always have more microstates. It tends to that configuration. So let me give you an example. Say I had a pencil, I put it right on this table on its tip, okay? And if I let go, what do I expect to happen in that case, Cary? Right? It would of course fall down, right? You'd experience that, and we just say it's because of gravity, right? But entropy also plays a role in that case, because there's only one microstate, or very few, in which the lead and the pencil is exactly balanced, right? The atoms have to be precisely configured, but if I were to let it go, it can fall in any direction. And so there's multiple other microstates in that case where that event can happen. So statistically, it's just more likely to go in that direction of higher entropy than just staying in a very organized state, as we say. And why does that relate to time exactly, right? That's because time, we measure time as a change, and in the process of measuring change, we'll notice that we'll have a more disordered state, and so time and disorder kind of correlate in that way. So we would say that time moves forward because of how entropy goes from we have an increasing entropy. Yeah, so that's one interesting idea there. Is there any other ideas that you want to say?
Yeah, I thought that was quite interesting, the way you explained the
pencil
falling
exactly.
over. I was also thinking, isn't there always a very low but still possibility that entropy could reverse? Like for example, if you let the pencil drop or let an egg fall, that it would just reverse, the pencil would come back up, or the egg would reassemble and then go back into your hand. Although it would be very, very low possibility, it would still be possible.
Yeah, definitely. That's correct. As you said, it's only a statistical probability, right? Of course, it's so unlikely. We just call it impossible because it's so unlikely it won't even happen in the lifetime of the universe. That's why no one ever expects it to you drop an egg and the egg comes back up, right? That's just not how we see it in our everyday lives, and that kind of matches our own description of what we talked about for entropy. And now also, would you like to move on to like another question? Maybe how does like time relate to the Big Bang? What was time like before the Big Bang? These are really big questions, of course, we're asking. But yeah, what are your thoughts on that as well? We did talk about change, so I'm thinking maybe those have something.
Yeah, I
to do
think it's
with
quite interesting because we like to think, as I mentioned previously, that time and change are interlinked. So before the universe came to be, like if for those of you who don't know, the Big Bang is basically what we call like the start of the universe. So before the universe was born, could there be any change to even be like cause time to exist? That's quite interesting. But for me, my personal take, as you mentioned in your theory B, the block universe theory, where everything's like a slice of a, as we move through time, we're experiencing different slices of an overall block. I think that the block must have been there before the universe ever started, right? Because the block and the block we can think of it as encompasses everything, even surpassing the universe. So there must have been slices even before the universe started. The Big Bang might have just been like one of those many infinite slices. So do you think that has some play, or would that be unrealistic?
Oh, I actually never thought of that. I guess you're right, because usually we call block universe. It's the collection of every single moment in the universe. But you're saying that the block could have existed before the universe. But I feel like that could be a bit contradictory, because then we wouldn't call it a universe anymore. And whatever existed before the universe, that would be included. So it should have a different name, right? I guess what I would think is that I feel like time may not exist. At least we don't know what happened before the Big Bang, but at least my opinion for now is that time may not exist before the Big Bang, and because, as you said, there's no change. At least let's try to imagine like a black void, okay? But even in that void, we would say there's no change, so it's time almost becomes irrelevant in that case. But another idea is that the moment we try to imagine a void, you're already putting yourself in that scenario, and the moment you do that, your consciousness is evolving as you perceive what's happening. And in that moment, time does start to become relevant again. So you see, us trying to even imagine before the Big Bang and what time is like already changes the definition of whether time should exist. So there's that really interesting, thought experiment there.
Yeah, I think that's quite interesting because a completely empty black void is a lot different than a completely empty black void with you in there thinking about it. Because then you would be analyzing the surroundings, yourself would be changing, and it's overall quite interesting.
Exactly.
Yeah. It kind of links with the thing like that common phrase where like someone tells you not to think about the elephant, but you think about the elephant.
Exactly. I'd say there's those thoughts.
Yeah, it's kind of like a paradox. You can't think about a completely empty black void.
Because exactly. The moment you think of it, it changes the answer to the question, right?
Yeah, it really affects your thing.
Exactly.
So I think that pretty much wraps up
our wraps the discussion
section, and that'll be everything for most of our podcast. And then Saahil, my co-host, will summarize everything that happened during the episode.
Yeah, of course. So for just our summary here, we talked about a definition of time, and I've also given a little bit of an insight onto special general relativity, what physics has to say, how time is dynamic, which is contradictory to our everyday intuition. And then we go into a little bit of philosophical implications from Augustine and Kant, who thought of time as a mental framework, and also time as an emergent property rather than fundamental as we think of it. And then at least what I said about A theory and B theory there, and how time flowing or we moving through time, right? Those two ideas there. And so then we had a discussion section. We talked about two different questions about whether time being the fourth dimension and the arrow of time, why does it move forward in one direction? And our discussion of entropy there, and then our second question, about like whether what time was like before the Big Bang, and whether we can even imagine that scenario, which is quite interesting there. And so yeah, that kind of brings us to that's the whole summary of the episode. And I also wanted to leave you with asking, what do you believe about time exactly? Do you think time is more of a mental framework, like philosophically? Do you believe in the block universe idea? Or do you think that time is dynamic and it's not set in stone? So yeah, that's just, I guess, food for thought, I guess.
And yeah, we hope you guys really think about this, maybe even brainstorm with your friends and family, because this is a way for you guys to also get engaged with our conversations. when you guys get asked a question, you get to think about an answer, and then hopefully in the next episode we'll come back, discuss our opinions on it, and then move on to the next thing we're gonna talk about. So that's it for today's
Yeah, that's it
episode.
for today's
Thank
episode.
you, and be
And
sure to
to
like and subscribe, and see you
and see
all
you
next time.